am Lakshmi Prasanna, Assistant Professor, Department of ECE, Institute of Aeronautical Engineering. In this session, we will discuss about the question bank related to Module 4, that is Advanced Microprocessors. So first we will see Part A, that is Problem Solving and Critical Thinking Questions. So here the first one is explain about the 4 functional blocks of 80286 Advanced Microprocessors. So here first we should know what are the different blocks that are present in 80286, and then we have to explain about each block, that is what is the function performed by the each block. So here 80286, it consists of these 4 functional units. So we have to explain about all these 4 functional units. So coming to the address unit, so we have to draw the part of the address unit indicating all the blocks that are present in the address unit and the operation that is performed by this address unit. So mainly with the help of all these blocks in the address unit, it is able to calculate the physical address. And second unit is bus interface unit. So here this is the bus interface unit block, and all these are internal blocks that are available in this bus unit, and the function that is performed with the help of all these blocks they are mainly meant for fetching the instructions from the memory. And after fetching the instructions from the memory by this bus unit, it is going to give for the next unit, which is called instruction unit, as a input. And another unit here is instruction unit. So the instruction unit consists of all these blocks like a decoded instruction queue, instruction decoder, and instruction unit. And the function performed by this main function with the help of all these 3 blocks, instruction unit is going to perform one important function that is called decoding. And the 4th unit is execution unit. So here all these are the blocks that are present in the execution unit. So mainly in the execution unit we have here ALU, and the function performed by this execution unit is, because of the ALU presence, it is capable of performing all the arithmetic and logical operations. And these are all the 4 blocks that are present in the architecture of 80286 Advanced Microprocessor. And the second one is illustrate about the mission status word in 80286 Advanced Microprocessor. That means here we have to draw the format of this mission status word. By seeing that format, we should clearly indicate what are the bits present in that format, and we have to explain about the function of each bit, importance of each bit in the mission status word. So here this is the mission status word format, and all these are the 4 important bits that are present in this mission status word. So it is a 16-bit register. So you will have the bits from D16 to D7. But here only the 4 bits are used. And after drawing this format, we have to explain the importance of each bit. So that means here the instructions, in order to make this mission status word enable, we have to use the instructions like load mission status word and store mission status word. And the 4 important bits that are present in the mission status word is, one is protection enable, PE, MP, that is monitor processor extension, and EM, emulate processor extension, and TS stands for task switch. So these are the 4 bits that are present in the mission status word in 80286 Advanced Microprocessor. So we have to write the function of all the 4 bits. And the next one is illustrate about the following signals available in 80286 advanced microprocessor. Here 80286 microprocessor is having more number of pins. So among different pins, here they have specified some of the pins and we have to write the function of all these pins. So here the first one is PEREQ, which represents a processor extension. So generally this is the pin we will use because this 80286 supports coprocessor. And next one is PEACK, that is processor extension acknowledgement. So this is the acknowledgement signal that is coming from the coprocessor to the original 80286 microprocessor. And the next signal is CODE and INTA. So here CODE represents code and INTA represents interrupt acknowledgement. And here we can see the next pin is CAPS. It represents the capacitance. So here CAPA represents the value of the capacitor that should be connected between the input pin and ground. And next pin here, busy. So if that busy signal is enabled, 80286 is going to suspend the execution and it will wait until the busy signal becomes inactive. And here, this is the error signal. So this signal will be enabled if there is any error during execution of the instructions. So if there is any mistake committed, then this error signal will be enabled. So all these are different pins that are present in this 80286 microprocessor. So considering all these pins, we have to write the function of each signal. So function of all that 6 signals in detail. And next demonstrate about the physical address formation in real address mode. So here we have to say how the physical address will be calculated when the advanced microprocessors are operating in this real mode. So generally when the advanced microprocessors are reset, they will simply act as 8086 microprocessor. The operation of that processor will be similar to 8086. So that is why when the advanced microprocessors are operating in the real address mode, the physical address formation calculation will be same as the physical address calculation how we have done for 8086 microprocessor. So we have done physical address calculation in 8086. So we have got the 20-bit physical address. That means first we have considered the offset address, its size is 16-bit. Next we have considered the segment address, its size is also 16-bit. But we have made that shifted towards left, or by making the segment address into 10, we made that as 20-bit data. And here is the adder which is going to add this offset address and segment address, and it leads to 20-bit physical address generation. So here when 80286 or when 80386 advanced microprocessors are operating in the real mode, the physical address calculation will be same as 8086. So in 8086 we have followed 2 procedures to calculate the physical address. In the procedure 1, we have considered the segment address, shifted that content towards left by 4 bits, and to that data we have added the offset address. So totally we are following this procedure as one procedure to find the 20-bit physical address formation. And another procedure we are following is going for the formula segment address into 10 plus offset address. So considering here segment address into 10 is same as considering the segment address and shifting that data towards left by 4 bits. Both are same. So these are the 2 procedures we will follow to calculate the physical address when the advanced microprocessor is operating in the real mode. And so here explain about the physical address formation in the protected virtual address mode. So this protected virtual address mode is also called as PVAM. So when the advanced microprocessors are operating in this protected virtual address mode, physical address calculation will be different. It is not same as 8086. So we have to consider this figure in order to calculate the physical address when it is operating in the protected virtual address mode. So with the help of this figure, first we have to consider the 32-bit virtual address, and it is divided into 16-bit selector and 16-bit offset. Again, the 16-bit selector is divided into 13-bit index and 1 bit for table indicator and 2 bit for RPL, that is requested privilege level. So with the help of this TI bit, the descriptor tables will be selected. If TI is 0, the global descriptor table will be selected. If TI is 1, the local descriptor table will be selected. So based on the TI bit, any one of the descriptor table will be selected. And from that, we are going to take the segment address. And to this segment address, we are going to add this offset address. So in the protected virtual address mode, we are going to get the 24-bit physical address generation. So this is the entire procedure we have discussed based on the previous diagram. And so illustrate about the page table and page directory entry by drawing the neat formats. So here this page table and page directory, these are the two components that will be used during paging mechanism. So here paging mechanism will be used in order to achieve the memory management efficiently. So here first for this page table, we should write what is meant by page table. And so here next, what is meant by page table, and then we have to draw the page table format. So it consists of totally 32 bits. So this is the page table entry format. And after drawing the format, we have to also say what is the importance of all these bits. And similarly here, we have to also say what is meant by page directory. So here this is the page directory, and we should indicate the page directory entry format. So this is also the 32-bit register format. So it consists of totally 32 bits. And after drawing the format, we should say what happens when these bits in the page directory entry and page table entry are enabled. So we can see here P represents parity bit, R by W, that is read write, U by S, that is user and supervisor. Okay, this is A access bit, and this is D dirty bit. So we have to explain about all these bits. So here we have to explain the bits regarding the function when they are enabled and when they are disabled. What is the function? So here enabling means that bit should be 1 and disabling means it should be 0. So that page table and page directory entry, totally it consists of some of the common bits and some bits are different. So here P represents present bit, and A means accessed bit, D means dirty bit, and OS reserved bits. All these are different bits that is available among the 32 bits of page directory and page table entry. And we have to consider each bit function when they are enabled and when that particular bit is disabled. And another bit also U by S, that is user and supervisor, R by W, that is read write. Now, so demonstrate on register windowing and massive pipelining issues in RISC processor. So these are the two pipelining issues that occurs during RISC processors. So in RISC processors, we have register windowing, massive pipelining, and some other issues also. But here, about register windowing and massive pipelining, we have to say what are the issues. So these are different issues that comes under register windowing technique. And here we have massive pipelining issue. So different issues are there during massive pipelining. So here for different process, we have to follow all these steps in order to overcome that issues. So these are the two issues in the RISC process during pipelining procedure. Now, so explain about the instruction latency and dependency issues in pipeline systems. So these are also the two issues that occurs in the pipeline system. So we have to also explain both, that is instruction latency and also dependency issues. So all these are the steps we have to follow in order to avoid this instruction latency issues. So these are the important 4 steps we have to follow in order to avoid this instruction latency issues. And similarly, we have to follow different techniques in order to avoid this dependency issues. So these are the 2 issues in the pipeline architectures. Now, so illustrate about the importance of paging and segmentation concept in 80386 advanced process. So here, what is the importance of paging and what is the importance of segmentation? So these are the 2 important blocks that are present in the architecture of 80386 microprocessor. So because of these 2 blocks presence only, compared to 80286, 80386 can have efficient memory management mechanism. So here the importance of paging means, so this is also one of the technique. Why? Because the entire memory is divided into pages, but here the entire memory will be divided into fixed size pages during this paging mechanism. So if we consider paging, the entire memory will be divided into fixed size pages. Whereas if we consider here segmentation, the entire memory will be divided into variable size segments. And so here in the paging mechanism, in order to complete one task, no need to be in the physical memory at any time. That means since the entire physical memory is divided into fixed size pages, each page location will be allocated to perform one task. So soon after that particular task is completed, it can leave the page so that the space of that particular memory will be empty and it will be allocated for a new task. And so this memory, it is going to, that is paging mechanism is going to achieve memory management. Okay. So all these are some of the advantages of using paging mechanism. Similarly, we have to also say here the importance of segmentation and how the segmentation will be done. So here in the segmentation concept, we are going to divide the entire physical memory into variable size segments. So this is segmentation is also one of the concept which leads to have efficient memory management mechanism. So the importance of paging and segmentation, this is the importance. Demonstrate about the physical address formation in the protected address mode. So here physical address calculation will be different for the real mode and different for the protected address mode. Okay. So here generally there are 2 methods can be followed in order to calculate the physical address during protected address mode. So here what are these 2 methods is, method 1, we can calculate the physical address by disabling the paging unit, and we can also calculate the physical address by enabling the paging unit. So here, this is the figure which represents the calculation of physical address in the protected mode without paging unit. So here inside we cannot see any paging unit in between. So this is one procedure we can follow to calculate the physical address. And this is another procedure in order to calculate the physical address during protected mode. And here the procedure is protected mode addressing with paging unit. So if we consider this figure, here we have an extra block which is called paging unit, and which will help to have the paging mechanism concept. So these are the two ways we can consider in order to calculate the physical address during protected mode. And so coming to the next part here, that is long answer questions. So here the first one is draw and explore the flag register format of 80286 advanced microprocessor. So here 80286 microprocessor consists of 16-bit registers. That is why the flag register size also will be 16-bit. So here the 16 bits are D0 to D15. So here draw the flag register format. So this is the 16-bit flag register format. But among the 16 bits, 11 bits are used here, whereas the remaining bits are undefined. Okay. So here the bits we can see, this is a carry flag, parity flag, auxiliary carry flag, zero flag, sign flag, trap flag, interrupt flag, okay, direction flag, overflow flag. IOPL means IO privilege level, and this NT stands for nested task. So after drawing the format of this flag register of 80286, we should also explain about the function of each flag in detail. Okay. So here are the different flags that are available in the flag register format of 80286. So in this we have discussed clearly when that particular flag is enabled. Okay, so when the parity flag will be enabled, when the carry flag will be enabled, that means when the ALU operations are done, the result of ALU will be reflected on this flag register. Okay, so here we have to say in detail when that particular flag bit will be set. And all these are the bits that are available in the flag register format of 80286 microprocessor. And so list out the 4 major processing units in 80286 microprocessor. So here if we have to draw the architecture of 80286, and we have to clearly indicate what are the 4 major processing units. So in 80286 architecture, we have important 4 blocks. We have to draw that, and then we have to clearly describe the function of each unit. So this 80286 consists of all these 4 major processing units, and the function of each processing unit is, if we consider here the first unit, that is address unit. So it consists of internally all these blocks. With the help of all these blocks, totally address unit is going to calculate the physical address generation. And the second block in that is bus unit. So the internal blocks that are available in the bus unit, all these blocks are available. So totally here bus unit is used for fetching the instruction, and it will be placed in the queue. And that instruction from the queue, it will be given to the next unit, which is called instruction unit. So next unit will be instruction unit. So the function of this instruction unit, so all these are the blocks that are present. The function of this instruction unit is, it is going to take each instruction from that queue. After taking, this instruction unit is going to decode each instruction one by one. And next it will be giving to the next unit, which is called execution unit. So execution unit consists of all these blocks, mainly ALU. So execution unit is going to perform all the arithmetic and logical operations. So all these are the 4 functional units that are present in 80286 architecture. And here the function of each unit is given briefly. And so illustrate the operating modes of 80286 advanced microprocessor. So 80286 microprocessor can be operated in 2 modes. The 2 modes are real address mode and protected virtual memory address mode. So that means here in the real address mode, how to calculate the physical address, what is the procedure. In the protected virtual address mode, how to calculate the physical address. So when this 80286 is operating in the real address mode, the physical address calculation will be same as 8086 microprocessor. That means by considering the segment address into 10, for that we have to add the offset address, and totally it is going to produce 20-bit physical address. But here the address calculation in the protected virtual address mode will be different, because that 80286 is a 24-bit microprocessor. So using this diagram here, protected virtual address mode. So based on this, it is going to calculate 24-bit physical address. And here this is the explanation regarding that protected virtual address mode. So using this mode, totally it is going to calculate 24-bit physical address. If it is real mode, only 20-bit physical address. And next, explain about the architecture of 80386 advanced microprocessor with a neat diagram. So that means here first we have to draw the architecture of 80386, and then we have to explain about the function of each block. So here this is the architecture of 80386. Totally it consists of 6 blocks, that is a bus unit, code prefetch unit, and instruction decoder unit, and execution unit, segment unit, and paging unit. So these are all the 6 blocks that are present in the architecture of 80386. And we have to explain about the function of all these 6 blocks. So here all these are the 6 blocks. So we have to explain the function of each block. So this is what about the function of bus interface unit. Next, code prefetch unit, instruction decode unit, and execution unit, control unit, and data unit. That means here in the execution unit, all the internal blocks that are available in the execution unit is, one is control unit, data unit, and protection test unit. And another blocks also, one is a segmentation unit. It is going to convert logical address into linear address. And the last unit is here paging unit, which is going to convert that linear address into physical address. So all these are the 6 blocks that are available in the architecture of 80386. And illustrate about the basic concept of 80386 advanced microprocessor paging system. So if we see the architecture of 80386, it consists of one important block which is called paging unit. So here they are asking what is the importance of that paging unit that is available in 80386 architecture. So that means we have to write what is the importance of paging. That means it provides memory management mechanism by dividing the entire physical memory into fixed size pages. Okay, so each page is allocated to perform one single task. After performing the function of each task, that particular memory can be leave empty so that the other task can be occupied. Okay, so all the advantages of paging scheme we have to consider here. And so in order to make this paging mechanism in 80386, it consists of three important units. They are paging unit, page directory and page table entry. And illustrate about different addressing modes available in 80386 microprocessor. So 80386 is having different addressing modes like 8086. One is register addressing mode. So whatever the addressing mode we are discussing here, after that we have to clearly indicate with an example. So here 80386 is the advanced microprocessor which consists of 32-bit extended registers. That is why here in place of registers we will have EAX and EBX, that is extended AX and extended BX, because these registers each is of 32-bit. And another addressing mode is immediate addressing mode. So here also we have to use 16-bit register. Next, direct addressing mode and register indirect addressing mode, based addressing mode. So for each addressing mode we have to write the example along with the function. And indexed addressing mode, scaled index addressing mode, based index addressing mode, and based scaled index addressing mode. So all these are different. Based index addressing mode with a displacement and based scale index addressing mode with a displacement. So all those are different addressing modes that are available in the advanced microprocessor. And explain the function of the signals that are present in 80386. So generally it consists of many number of pins, but here the function of these pins are asked. So here the 6 pins here, the first one is BE0 to BE3. So they represents byte enable. So 4 byte enable signals will be there. And W by R, which represents read and write. D by C stands for data and control. And ADS means address status. And NA stands for next address. And BS16, it represents bus size is 16. Okay. So all these are different pins that are available in 80386. And we have to clearly write here the function of each pin. And illustrate about the real mode and protected mode concept of 80386 microprocessor. That means here these are the two operating modes of 80386. When 80386 is operating in the real mode, how to calculate the physical address. When it is operating in the protected mode, how to calculate the physical address. So when it is operating in the real mode, the physical address calculation is same as 8086. That is why the physical address calculation, whatever we are doing, the same procedures we can follow. So 2 procedures are there. Any procedure we can consider. So using these procedures, when it is operating in the real mode, only 20-bit physical address can be calculated. And another mode is here protected mode. So when it is operating in the protected mode, it is going to calculate the physical address by using 2 methods. Here in method 1, to calculate the physical address in the protected mode, we can calculate by enabling this paging unit or disabling this paging unit. So anyway, we can find the physical address calculation. Now, so in this case, this is an example to calculate the physical address in the protected mode without paging unit. So here there is no paging unit. And this is another procedure calculating the physical address in the protected mode by enabling the paging unit. So if you see here, this is the paging unit which is providing the paging mechanism. Next, outline the flag register format of 80386 microprocessor and explain the function of each flag. That means we have to first draw the flag register format of 80386. And this is the flag register format. It is 32-bit. So if you see here, 0 to 31, these are the 32 bits. After drawing the flag register format, we have to explain the function of each bit. So out of this 32-bit flag register, only some flags are used here. So here, as we know, CF stands for carry flag, sign flag, zero flag, parity flag, trap flag, interrupt flag, direction flag. Okay. And another flags here, auxiliary carry flag, overflow flag, all these are the flags that are available in 8086 also. But in this 80386, here we have advanced bits like IOPL, that is IO privilege level, nested task, resume, and VM stands for virtual mode. So all these are the bits that are available in the flag register format. And we have to write the function of each bit, explain about each bit. And explain in detail about the register organization of 80386 advanced microprocessor. That means here we have to say in this 80386 advanced microprocessor, how many number of registers are there. It says the register organization. So totally all these are the registers that are available in the register organization of 80386. So after listing how many number of registers are there, okay, so what is the size of each register? So here if we consider all these registers are of 32-bit registers, but here if we consider these registers are of only 16-bit, but here these two registers are again 32-bit. We have to list out all these and we have to explain about each register that is available in the register organization of 80386. So EAX means accumulator. So in all these cases here E stands for extended. That means that register size is extended to 32-bit. So BX is base register, CX is counter register, and DX is extended accumulator. And along with this we have different pointer and index registers like base pointer and stack pointer. And index registers, destination index and source index. So these registers are also of 32-bit. And segment registers, that is a code segment, stack segment, data segment and extra segment. Along with that, the new segment registers are here FS and GS. And instruction pointer, that is IP, it is also extended, that is 32-bit. So all these are the registers that are available in the advanced microprocessor. So explain briefly about the segmentation and paging concept in 80386 microprocessor. So in 80386 microprocessor, these are the two important units that are present in the architecture, which are producing the efficient memory management mechanism. So considering that, we have to write the importance of paging unit and the importance of segmentation unit. And so outline the features of Pentium process. So from 80586 advanced microprocessor, we call that processors as a Pentium process. So considering that microprocessor, we have to write what are all the features of that Pentium process. While writing the features, we have to concentrate on the size of data bus, whether it is supporting pipelining or not, how many execution units are present. Okay, so how many execution units are supporting integer calculation and floating point calculations, and what are, if there are any issues in the pipelining mechanism, how it can overcome. That means these processes will be having one important logic which is called branch prediction logic. Okay, so how about the architecture, which type of architecture this Pentium process supports. So all these features we have to write related to Pentium process. And next, demonstrate on branch prediction process in Pentium processor. So this branch prediction logic is there in the Pentium process. Why? Because in the normal process, since they are supporting pipelining, if any branch instruction occurs in between, so there will be a disturbance in the execution of instructions in the pipelining mechanism. In order to overcome that drawback, we are going to use one important logic which is called branch prediction logic. That means using this logic, we can predict before itself the occurrence of the branch so that the problem can be avoided. So how we are going to predict means by using some important bits like valid bit and history bit. So these are the two bits that are present in the directory entry. So how the branch prediction, that means how the prediction can be done before itself than the actual occurrence means with the help of the history bits. That means we have to indicate whether the branch is strongly taken, weakly not taken, and strongly not taken. So this is the figure that supports the branch prediction logic, and this is the table and the process that will occur if branch is taken and if branch is not taken, and when the history bits are maintained in this manner. And so compare RISC and CISC process. So here RISC stands for reduced instruction set computer and CISC stands for complex instruction set computer. That means both these processors are different based on the instruction set. Okay. So here we have to write the differences, like CISC architecture gives more importance to hardware, whereas RISC means importance for software. So CISC means complex instructions, but in the RISC reduced instructions will be very simple. So CISC process, they can access memory directly, whereas RISC, it requires registers to access the memory. So coding in CISC processor is simple, whereas coding in RISC processor requires more number of lines because the instruction is simple. So in order to write the same program, more number of instructions should be used. So as it consists of complex instructions, it takes multiple cycles to execute. But since the instructions are simple in the RISC, it takes only single cycle to execute. Okay. So all these are some of the differences we have to write regarding CISC and RISC process. And what are the advantages of RISC process over CISC process? So here some of the advantages are RISC is having a simple instruction set. So that particular instruction can be executed within a single cycle. The speed of operation, execution time can be minimized. The instruction formats will be very simple. So all these are some of the advantages of RISC architecture. So here these are the disadvantages of CISC architecture, because here since the instruction is very complex, in order to execute it requires more number of clock cycles, and all these are some of the disadvantages in the CISC architecture. So we have to consider all these disadvantages. And so explain about the design issues of RISC process. That means when based on the architecture of this RISC process, what are different design issues? So here the design issues are, it is having simple addressing mode and a simple instruction format. It consists of simple instruction formats, performance using optimizing compilers, and high performance of instruction execution, and VLSI implementation of control unit. So all these are the different design issues that are present in the RISC architectures. And what are different performance issues that is present in the pipeline systems? So different performance issues are there in the pipeline system. One is instruction latency. So we have to explain what is meant by instruction latency, and we have to also say what are different steps we have to follow in order to avoid that instruction latency issue in the pipeline system. And another issue is here dependency issues. So here are some of the steps or techniques that are given in order to avoid that dependency issue. And distinguish between 80286 and 80386 microprocessor. So here we have to write the differences between these two based on the features of that microprocessor, advanced process, and also regarding architecture. Like what is the size of the data bus in 80286 and 80386. Okay. And here, what about the memory that is available in 80286 and how much amount of memory is available? How much amount of physical memory and how much amount of virtual memory? What is the size of the registers? What is the size of the address bus? How many modes 80286 and 80386 can be operated? So all these differences we have to consider. And what are the advantages of 80386 over 80286? So here, if we compare the features of 80286, all the features will be advanced in 80386 regarding data bus size, address bus size, memory size, regarding operating modes, size of registers, regarding size of the virtual memory. So regarding all these aspects, the features of 80386 will be advanced compared to 80286 microprocessor. So 80386 supports this paging mechanism and segmentation mechanism. That is also one of the advanced feature. And define segmentation. What are the advantages of segmentation process? So here first we need to write what is meant by segmentation. So for example, if we consider 8086, it is supporting segmented memory. 4 segment registers are there. So it is divided into 16 logical segments. Each segment size is of 64 KB. And we have to calculate the physical address based on the segment address and offset address. So in this case, what are the advantages of segmentation means? So code related information will be in the code segment, data related information in the data segment. Okay, stack related information will be there in the stack segment. So because of this process, in order to access anything, it is very easy. Okay, that is the main advantage of segmentation. And coming to the part C here, that is short answer questions. So what are the features of 80186 advanced processor? So here in these features, we have to write some features like the size of data bus. Okay, how many registers are there? What is the size of the registers? What is the size of the memory? And internally, what are different chips, ICs that are available? Okay, what is the operating frequency? So all these features we have to write. So whatever the microprocessor is, so as we have seen previously, the features are asked for 80186. Now here, the salient features of 80286 advanced microprocessor is asked. So considering the same features like size of data bus and frequency, about instruction set, how about the memory management? Okay, so how many operating modes it can support and how many pins that microprocessor consists of, and in how many operating modes it can be operated. So all these features we have to write regarding any microprocessor. So in this question, basic features of 80386 microprocessor is asked. Similarly, we have to write such that this 80386 is having 2 units, which is called paging unit and segmentation unit. So because of that, memory management can be achieved. And all the registers that are available in 80386 are extended registers because they are 32-bit in size. So that is why physical address generation will be 32-bit. So all these are different features. And define virtual memory. So here virtual memory means that is the extra memory taken from the hard disk. So in some cases there will be complex instructions which need to be executed. And in such cases, the physical memory is not sufficient. So in that case, we are going to use the separate memory from the hard disk, which we can call it as virtual memory. And outline the flag register format of 80286 microprocessor. So that means we have to just draw the flag register format of 80286. So flag register of 80286, it is a 16-bit register, and we have to indicate all different flags that are available inside this register. And what are different interrupts available in 80286 advanced microprocessor? So as we have seen in the interrupt vector table, other than dedicated interrupts, after that classification, the remaining interrupts, those are called reserved interrupts. Why? Because they are reserved for advanced microprocessors. So here all these are the different interrupts that are available in 80286. And here the function of each interrupt is given. And list out the registers in the register organization of 80386. That means 80386 consists of how many number of registers? Okay. So all these are different registers that are available in the register organization of 80386. So if you see 80386, some of the registers, here there is a prefix E which represents that they are extended. It means their size is 32-bit, and the remaining register size will be only 16-bit. And list out different signals of 80386. That means what are signals means here? Pins. So we have to just list what are different pins that are available in the pin diagram of 80386. So here all these are different signals of 80386. So each signal full form is also indicated here. And list out the advantages of paging in pages in paging. So here generally paging mechanism is there in order to provide the efficient memory management mechanism. So here we have to write some of the advantages when the physical memory is divided into fixed size pages. And write different operating modes of 80386 microprocessor. So 80386 microprocessor can be operated in different modes. That is 3 operating modes it has. One is real mode, another one is protected virtual address mode, and the last one is virtual mode. So these are the 3 operating modes of 80386 microprocessor. And next one is what is real address mode. So this is one of the operating mode of advanced microprocessor. When the advanced microprocessor is operating in the real mode, the physical address calculation will be same as 8086. Or when the advanced microprocessor is reset, any microprocessor that is 80286 or 80386, when they are reset, so they will be operating in the real address mode. That means their operation will be same as 8086. And what is protected address mode? So this is also one of the operating mode of advanced microprocessor. But in order to calculate the physical address when it is operating in the protected mode, it will give a 32-bit physical address. And why segmentation mechanism is preferred in advanced microprocessor means only one reason, that is to achieve memory management mechanism. And list out the features of Pentium process. That means the advanced microprocessors from 80586 we call as Pentium process. So here we have to indicate some of the features of Pentium process, like what is the size of the data bus, okay, so whether it is supporting pipelining or not, how much amount of cache memory is available, what about the execution units, how many number of execution units are there, okay, and whether it is supporting branch prediction logic or not. So all these features we have to indicate. And what is the importance of branch prediction logic in Pentium process? So in order to avoid the issues in the pipeline, we are going for the important logic which is called branch prediction logic. So here, in order to avoid pipeline problems, we are going for branch prediction logic. So this branch prediction logic is available in the Pentium process. And distinguish between RISC and CISC process. So RISC stands for Reduced Instruction Set Computer and CISC stands for Complex Instruction Set Computer. So we have to write the differences between these two regarding the instruction set, how they will be executed, how many number of clock cycles are required, so which processor is slow, which instructions will occupy more amount of space. So all these aspects should be compared between RISC and CISC. And list out the basic features of RISC process. That means we have to write RISC stands for Reduced Instruction Set Computer. Since the instruction set is very simple, the execution time will be less. So in order to execute one instruction, it requires only one clock cycle. Each instruction execution time will be uniform. So since the instruction is simple, we have to write more number of lines in the program. So all these are different features of RISC process. So here, in addition to that, we have to also consider this. And what are different issues involved in the RISC-based process means, here the main issues that are available in the RISC processors are, one is simple addressing mode, simple instruction formats, performance using optimizing compilers, and high performance of instruction execution and VLSI implementation of control unit. So all these are different issues that are present in the RISC-based process. And how pipeline process is performed in the RISC process. So this RISC process will support the pipeline mechanism. So here pipelining means multiple instructions will be executed in the overlapping manner. And this is the representation in order to say how the pipelining process will happen. So here you can see when the first instruction is fetched, in the next cycle it will be decoded. When the first instruction is decoding, the second instruction can be fetched. And when the when the first instruction comes to the execution, the second instruction can be decoded and the third instruction can be fetched. So this is what called executing the instructions in the overlapped manner, which is called pipelining. And so list out the performance issues in the pipeline system. So some of the performance issues here, it is indicated. So one is pipeline increases the CPU instruction throughput, and pipeline does not reduce the execution time of individual instruction, and the execution time of each instruction overrun, pipeline implementation due to increased control overhead of pipeline, and pipeline stage register delays. So all these are different performance issues in pipeline systems. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.